This video is about a standard 40-foot container. It'll show all the features of your standard 40-foot high cube container, which is the best container in my opinion for building with. Here we're at the front end of the container. This is the end where if you mount it on a truck, the tongue of the truck will go underneath of here. And the corners are made out of basically steel angles that come up the sides to strengthen the corners. And at the top and at the bottom, we've got the standard connectors, which are described in detail by ISO. It's really important when they manufacture these that the connectors are consistent with the holes, the position of the holes, and the thickness of these. So when you can use the same type of connection fitting to hold these together, and the connectors will match up together properly. That gives us some advantage in construction when we get into it, because that is something that will be consistent between the containers. Now, one of the issues that I have with containers, take a look here. We have a slight distance from the bottom of the side rail down to the bottom of the connector. Come up here and we'll see the same thing. Take a look there. There's a bit of a distance between the top of the connector and the top of the top rail. So when we stack these together, we've got a gap between them of about 1 3/4 inches, which gives us some problems as far as deflection and carrying the loads on down. Let's take a look inside. All right. Now, on the inside, we've got here plywood floor. It's made out of a mahogany type of lumber. It's oftentimes treated. This floor does not smell like it's treated. It has more of just a wood smell. Some of these floors are treated with a very noxious pesticide, which can be quite a problem and represent a liability risk. When assembling these, we have to take that into consideration. Now, here I am at the rear. We've got these angles that I showed you earlier on the outside that strengthen the corners. And when we get into doing the construction with these containers, if we take out the side corrugations, we lose some strength here. And oftentimes we have to add a stiffener in here to make it work. And as we go down here, you can see the top rails. Some containers, the top rail here, some containers are built without them. The top rail does not provide much strength. We can cut out about 8 to 10 feet of these corrugations and the container will still stay standing under its own strength. But if we cut out more than that, we have to run either a channel or some other stiffener down along the top to stiffen the container. Now, one of the interesting things about containers, we have these cargo tie downs. These can actually help us when we work with the container, because one way to build the structure, if we take out the sides of the container, on the side of the container, we can run a cable. We've done this before, up through here, across to this connector, and on to the other container next to it, and on down, and provide a suspension. These are spaced fairly close together, so this gives us another way of supporting the roof of the container if we cut away the sides. The sides of the container are cold form corrugated steel. They are 0.07 inches thick. I believe it's 4 millimeters thick in metric. The side channels, if I remember right, in metric, is 6 millimeters thick. The door is very thick. One way that we can make a balcony on containers is we can open the doors. We can weld them open at the hinges, and we can support the balcony from the door. Works very well. And we see here that the threshold is stiffened. We have the stiffeners around the frame here. If we cut out the end here, the end corrugation, The frame around this end is not strong enough for any kind of wind load because it counts on these corrugations providing the stiffness. If we cut this out, what we have to do is we either have to cross brace or we have to build a frame on the inside of the container to stiffen it. On the other hand, if we remove these doors, in most cases, we don't have to do anything on this end because the way this is constructed, this frame is stiff enough to take the lateral loads that the container gets without doing any additional work. This concludes the 40-foot container. There is shop drawings available through various websites for how these are constructed. And I would recommend, if you get into engineering these, that you get a hold of shop drawings of how these are constructed in order to get all the section data to do the analysis. This concludes this video.